For us at the Finnish Meteorological Institute, we are very interested about comparative planetology, like how the atmosphere behaves on Mars and how it behaves on Earth, what there is common, what differences there are, and what we could learn about Earth by studying Mars. To study the atmosphere, we have to be able to make measurements during many years and compare the measurements to the previous one and combine the measurements with other stations also. The Perseverance rover has in total 7 scientific instruments. One of those is MEDA, which is like a weather station on Mars. MEDA comes from words Mars Environmental Dynamics Analyzer. We have delivered for MEDA 2 instruments that measure pressure and relative humidity of the atmosphere of Mars. There's also many other sensors on MEDA which measure, for example, the air temperature and wind speed, dust properties in the atmosphere, and the same things basically that the weather station could measure on Earth also. The humidity instrument is located in a Perseverance neck. It has a white filter to protect it from the dust. The pressure sensor is located inside the rover, where it's nice and warm, good conditions, and it measures pressure only through a small inlet which is covered with the filter to protect again from the dust. Measuring the atmosphere is really important for making, for example, weather predictions on Mars. We want to send more than one weather station on Mars, because on Earth you would also not expect to predict the weather, the whole planet with one weather station. To be able to model the atmosphere of Mars, we need multiple weather stations on the surface. Now we have Perseverance and Curiosity, and also InSight has a weather station with some parameters measured. And in the future we will have ExoMars 2023 landing, which would give us in total 4 weather stations on the Mars. For each mission, the instruments are always custom made, and for each mission we try to improve our instruments. And these Perseverance instruments have new advanced sensor heads compared to Curiosity, for example. And Curiosity has been measuring over 9 years, so we expect a long lifetime from the new instruments also. Mars is a quite rough environment for the instruments. It's generally very cold, and the atmosphere is thin and it's made of carbon dioxide. And there's dust everywhere, so we have to cover our instruments from dust. For example, close to the equator during the summer, there can be plus 20 degrees Celsius warm, and during the night it can be minus 70. So the changes are quite huge that the instruments have to survive. So even with these rough conditions, we have to be able to make reliable and high-quality scientific measurements. Everything has to be absolutely reliable because there's no repairman on Mars on site. Everything starts with the tiny sensors by Vaisala, and we built the rest of the instrument around the sensor heads. Also, we have to choose all materials and electronic components so that they can endure the cold environment on Mars, the long interplanetary travel, and then they have to be absolutely reliable. Everything is manufactured inside a clean room by specialists, for example, space-certified solderer. Everything is also inspected many times during the manufacturing process to make sure that it is exactly as we intended. For scientific instruments, it is not enough just to survive the launch, the travel and the landing. They also have to be able to make high-quality measurements on the surface. These instruments are mainly tested in FMI in our own laboratory. we are able to simulate the Martian environment inside small vacuum chambers. We test the instruments with multiple models during many years in the development process. For example, of the humidity instrument, we built in total 13 different validation models to test the new HUMICAP sensor heads, that they can endure the temperature ranges, for example. And the flight models are delivered for MEDA, and they are integrated to the MEDA weather station and then tested again. The MEDA station is then integrated to the whole Perseverance rover, and then the whole rover is again tested. FMI and Vaisala have been doing cooperation for many decades with this Mars instrumentation, starting from Mars 96 in the 90s. In total, we have been involved in over 40 space missions. 7 of those are Mars landers. Currently, there is a set of our pressure and humidity instruments on board Curiosity. In 2022, there will be another launch for ExoMars mission, where we also will have the similar set of pressure and humidity sensors.